So to graph cosecant, I look at the parent function, and I see that if I look at this period, there's a vertical asymptote at the beginning of the period, the middle period, and the end of the period. Okay, so there's no phase shift, so the only thing that can affect the vertical asymptotes is the period. And again, the parent function period is it's 2 pi. So 2 pi over b, and b in this case is 3. Okay, so if I consider the period to start at 0, it will end after 2 pi over 3 additional units. Okay, and again, for cosecant, the vertical asymptotes are beginning, middle, and end of the period. So put a vertical asymptote at the beginning, the end, and then halfway in between 0 and 2 pi over 3 is 1 pi over 3. Okay, so what else do I know about the cosecant function? Halfway between the first two vertical asymptotes, there's an upwards opening curve, and the vertex is halfway between the two asymptotes. Okay, so halfway between 0 and pi over 3 is pi over 6. There's no midline shift, so midline is still y equals 0. And the amplitude is 1. So the amplitude tells me how many units above the midline to go for the vertex. So in this case, it's the same as the parent. I go 1 unit up from the midline to hit the vertex. Okay, and then I know that this is the vertex of an upwards opening curve. Okay, in the second set of, or between the second set of vertical asymptotes, I know this time the cosecant graph opens downward, but again, the vertex is halfway between these two vertical asymptotes, and it's the amplitude down from the midline. Okay, so halfway in between pi over 3 and 2 pi over 3 is pi over 2, and the midline is 0. Since the amplitude is 1, I go down 1 unit to -1. Okay, and then I make that the vertex of a downward opening parabola. Okay, so next we have 3 times the secant of x minus 5 pi over 6. So this time there's no k value. There is a phase shift. Amplitude is 3. Period is again 2 pi over b, and b is 1, so just 2 pi then. Okay, so now I want to look at my basic secant graph. Okay, so I'm going to focus on the period from here to here. Okay, so normally my vertex of the upward opening parabola is at 0, but because there's a phase shift, the vertex will occur at 5 pi over 6 instead. Okay, so now where should the vertex be exactly? Well, the vertex, the y-coordinate, is the amplitude up from the midline. Okay, so there's no midline shift, so my midline is y equals 0. But this time the amplitude is 3, so my vertex should be 3 units above the midline. Alright, so what about the vertical asymptotes? Well, I know that from this vertex to the asymptote is, for the parent, it's pi over 2 units away, from 0 to -pi over 2. But the whole period is 2 pi, so it would take 4 of those distances to fill up the whole period. So I have 1/4 of the period to the left. Okay, so in this case, the period is also 2 pi, so again I want to go 1/4 pi, or sorry, 1/4 of the period, which I'll calculate off to the side. Okay, so I figured out that 1/4 of the period is worth pi over 2, So from the vertex, I go pi over 2 units to the left. So to go to the left, I subtract, find a common denominator, 2 pi over 6 reduces to pi over 3. Okay, so at pi over 3 is where I have a vertical asymptote. Okay, and then remember our vertex point is always halfway between vertical asymptotes. So if I go pi over 2 to the left to hit an asymptote, I can also go pi over 2 to the right to hit an asymptote. So to go to the right, this time I'll add pi over 2. Okay, so there will be another vertical asymptote at 4 pi over 3. Okay, so I know that this is the vertex of an upward opening curve. Okay, so I know that vertical asymptotes are evenly spaced. Right, so for the parent function, the asymptotes are pi units apart, and it's the same thing here. Right, the period didn't change, so the vertical asymptotes are also pi apart. Pi over 3 plus pi is 4 pi over 3. So if I add another pi to 4 pi over 3, I get the next vertical asymptote is at 7 pi over 3. Okay, and again, I know that halfway between these 2 points will be a vertex. So halfway between 4 pi over 3 and 7 pi over 3. So I can use the midpoint formula, add the 2 coordinates together and divide by 2. Okay, so 11 pi over 6. Okay, so I know that this time it'll be at a lower vertex. So again, amplitude tells me go down 3 units from the midline. And this one opens downward. All right, so first thing we want to factor because we need to get the b value out. So this time the variable is getting divided by 4, meaning it's getting multiplied by 1/4. So when I factor out 1/4 from pi, it becomes just, or sorry, once you factor out 1/4 from pi over 4, it becomes just pi. Okay, so now I can fill out this information. Midline shift is -2, phase shift -pi, amplitude is 1, period. So this time we do have a b value that's not 1. So 2 pi over 1/4 is 8 pi. Okay, so let's look back at the secant function. Okay, so again, the secant function normally has the vertex of the upwards curve at 0, but this time our phase shift of -pi means we're going to move that pi units to the left. Okay, so instead of at 0, my point's going to be at pi, or -pi, excuse me. And I also want to factor in the midline shift of -2. Okay, so where should this vertex occur? So from the midline, the amplitude says go up 1 unit. Okay, so from -2, I go up 1 unit, and now I'm at -1. Okay, now what about asymptotes? Okay, so again, I know that from the vertex, I go left 1/4 of the period to get to my first vertical asymptote. So in this case, my period is 8 pi, so 1/4 of 8 pi means the closest vertical asymptote is 2 pi units to the left. Okay, so I go 2 pi units to the left, and that's where my vertical asymptote is. Okay, and I'll just at the same time go 2 pi units to the right to hit my next vertical asymptote. And then, okay, so the distance between these two vertical asymptotes is 4 pi. So I know if I go another 4 pi, I'll hit a third vertical asymptote. Okay, so I know this one goes upwards, so something like this. Okay, so now what about in this section? So I know that after the upwards, I have a downwards opening one. So from the midline of -2, the amplitude tells me go down 1 more unit. So now I'm at -3. And my x-coordinate is halfway between pi and 5 pi, which is 3 pi. Okay, back to cosecant. So midline shift is 2, phase shift none, amplitude is 3, period b is 1, so 2 pi over 1 is just 2 pi. Okay, so looking at the cosecant function. So cosecant has vertical asymptotes at the beginning, middle, and end, starting at x equals 0. Okay, so again, no phase shift, so we do have a vertical asymptote right at 0. And then the period of 2 pi means that from 0, 2 pi units later, the period ends. So vertical asymptote at the end of the period, and another vertical asymptote in the middle of the period. So halfway between 0 and 2 pi is 1 pi. Okay, so this time midline shift is +2. Okay, so cosecant halfway between the first two asymptotes is my vertex. So halfway between 0 and pi is pi over 2. And then from the midline, I go up the amplitude. Okay, so the midline is 2, amplitude says go up 3 more. Okay, so now I'm up to 5. And then I know this is the vertex of an upwards opening curve. Okay, then between the other two vertical asymptotes, halfway is 3 pi over 2. So from the midline of 2, now I go down 3 units. So 1, 2, 3, now I'm at -1. And this one opens downward. Okay, so now doing some problems where the graph is given. Okay, so here we're asked to use secant. Okay, so first I can identify the midline by just looking at what's halfway between the vertexes or vertices. So this vertex is at +1, this vertex is at -3, so halfway between them is, -1. Okay, and you can just verify by looking that it's halfway between. Okay, so this tells me that the midline shift is -1, so that means that k is -1. Next, I would want to look at the period. So looks like, so I'll look at this period, I suppose. So from pi over 2 to 3 pi over 2 is how long this period goes. Okay, so again, here's pi over 2, here's 3 pi over 2. So 3 pi over 2 minus pi over 2 is 2 pi over 2, or just pi. Okay, so the period is pi. And I know that for secant, the period is 2 pi over b. Okay, so if the period is pi, what does b need to represent in order for this to be true? B has to be 2. Okay, what about a phase shift? So I know that for secant, the initial value is supposed to be the vertex of the upwards opening curve. So in this case, at 0 is not the vertex. The vertex got shifted over to the left. Okay, and how much did it get shifted? It got shifted pi over 4 units to the left. Okay, so since it's to the left, that means it's negative. So h is negative pi over 4. Okay, and how about amplitude? So from the midline, the vertex is 2 units up. Okay, so that's all 4 transformations. Okay, so using secant, amplitude, period. Okay, so remember it's, oh, sorry, not, okay, so using our variable, it's x minus h, but h is negative 4, so x minus negative pi over 4 becomes x plus pi over 4, and then midline shift. Okay, and then looking at this one, so I'll start with the midline. What's halfway between 2 and negative 2? Well, that's 0. So since the midline shift is none or 0, that means that k is 0. Okay, how about the period? So remember, this whole thing is one period. We need to include both the upward and downward facing portions. So this period goes from negative 2 pi to 2 pi. So that means the period is 4 pi. And because the period is 4 pi, and that has to equal 2 pi over b, that means that b must equal 1/2. Okay, what about a phase shift? So let's compare it to the parent secant, cosecant function. Okay, so cosecant has a vertical asymptote at 0 with the upwards to the right and the downwards to the left. And that's exactly what we have here. Vertical asymptote at x equals 0, upwards opening to the right, downwards to the left. So this time there is no phase shift. So that means that h is 0. Okay, and finally amplitude. So from the midline, this vertex is at 2, meaning it's 2 units up. Okay, so putting this all together using cosecant, amplitude times the function times b times the variable, no phase shift, and no midline shift.